Hello students, this is Rashie Kohli from Savannah High School. Today we will be discussing about polynomials. So what is a polynomial basically? The word poly means many, and the word nomial means terms. So we would be discussing about many terms. That's what the polynomial means. Okay. So the content of the presentation is standard learning targets, deconstructed standards, academic vocabulary, standard form of polynomial, addition and subtraction of polynomials. So the expectation and materials needed for this topic are, you need a notebook, paper, pen and pencil, and if you want colors, you can do a color coding with the problems. The expectations are, you must complete your work independently with a positive mindset. Use a strategy that works best for you. There are many strategies that you can use to add or subtract polynomials. So this is a standard from Algebra 1. That standard is APR 1. It says add, subtract, and multiply polynomials. Understand that polynomials form a system analogous to the integers in that they are closed under these operations. So we'll be working on performing basic operations. Today we will be discussing about addition and subtraction. So the learning targets for this presentation goes, I can understand polynomials, I can perform addition or subtraction of polynomials. So what does my standard means? Before we go ahead and directly work on our problems, we should understand the academic vocabulary and what does the standard is trying to tell us. So the word perform means to complete arithmetic operations like plus, minus, multiplication. In this standard, we are only covering three things: addition, subtraction, and multiplication. The word polynomials, as I said before, the poly means many, nomial means terms. Form a system of method analogous. The word analogous means similar. How you add integers or how you add other numbers, we're going to work on the same method in polynomials. So, why you are studying polynomials? There's a real-time example. Suppose you go for a shopping and you might want to know how much 3 pounds of flour, 2 dozen eggs, and 3 quarts of milk cost. Before we go ahead and find out how much does each item cost, we should know how to construct a polynomial. So for example, we have flour. Let's say it is represented by F. We have eggs. This is represented by E. And we have milk. This is represented by M. And for example, you need to find out how much is 2 dozens of egg plus 1 gallon of milk. So this 3 means 3 pounds of flour and 2 dozen egg, 1 gallon milk. This basic equation, when you go for a shopping, this basic equation is nothing but a polynomial. So this basic algebraic expression is now ready for you to input the prices. For example, if it costs $4.49 of flour, each flour when you take it, and $3.59 a dozen of egg. So you need to substitute that into the equation given in the blue. And for milk, it costs $1.79 a quart. So you can change that equation and your equation will look like 3 times 4.49 plus 2 times 3.59 plus 1 times 1.79. And in this step, we will solve by multiplying the number enclosed in parentheses with the number outside. So this is just an introduction of how polynomial will work. Plus, you will have a tax according to that. So our equation will, when you solve it, it will be $26.02 at checkout. So this is just a basic real-time example of how you can use polynomials in supermarket. So now let's start with academic vocabulary. What vocabulary do you need to solve polynomials? We have spoken about that poly means many and nomial means terms. So if I say what does one thing means? For example, if you have a packet of Doritos, it is one. So a number, a variable, or a product of a number that has one or more variable, it's monomial. Mono means one. For example, 4, 4x, 5x squared. These are single terms that are not separated by addition or subtraction. So this is a monomial. Binomial. A polynomial with exactly 2 terms. Let's take an example of a real-time example in front of you, the bike. Bike has 2 tires. So when a number is separated by addition or subtraction, it forms 2 terms. For example, 2x plus 3. It has 2x and it has 3. So that's a binomial. 4x plus 5x squared. It has 2 terms that are separated by plus sign. So this is a binomial. And we have 3x plus 1. These are 2 terms, so this is a binomial. Here comes trinomial. So suppose you go for a movie and you are interested in buying popcorns, Coke, and a bag of chips. So when you go to a counter, they will add up all. Because you are buying 3 things, tri means 3, that have exactly 3 terms. So let's take an example of a trinomial. So we have said monomial means one term. That is, if I use x, for example, binomial means 2 terms. If I use x squared minus 3, I can use addition also. Because there are 2 terms that are separated by minus, this is a binomial. Trinomial. Tri means 3. So this is 3 terms. If I write x squared minus 3x plus 4. We have 3 things that are 3 terms that are separated by plus and minus. So this becomes trinomial. Now next comes polynomials. Polynomial means many terms. If I have more than 3 terms, that's a polynomial. And all these monomial, binomial, and trinomial, they form polynomials. So example for polynomials can be x to the power cube minus 3x squared plus 2x plus 4. Now you can see it has 4 terms. 1, 2, 3, 4. I can have more than 4, and that will be a polynomial. Okay. So like I said, how does it make a connection? Monomial, binomial, trinomial are all subparts of polynomial. They all make a polynomial. And that's the connection between a monomial, binomial, trinomial, and polynomial. So our essential question, we go back to our learning target, that I can understand what is a polynomial. A polynomial is something which has more than one term. That's a polynomial. These are some examples of monomial that says one term is 2x, binomial 2x plus 3y, trinomial 2x squared plus 3x plus 5, and polynomial 3x cubed plus 2x squared minus 6x plus 2. You can see right here, monomial means 1, binomial means 1 and 2, tri means 1, 2, and 3, and polynomial means many terms, 1, 2, 3, and 4. Standard form of polynomials. So when the terms of a polynomials are arranged from the largest exponent to the smallest exponent in decreasing order. So I repeat, when the terms of polynomials are arranged from the largest exponent to the smallest exponent in decreasing order. For example, when you see on screen, we have 6x to the power 8 minus 7x squared minus 5x plus 8. We have a decreasing exponent. You start from 8, then you go down to 2. After that, you have 1. So that is a decreasing order of exponent, and that is a standard form of polynomial. But if you look at example number 2, it is 7x squared plus 6x to the power 8 minus 5x plus 8. In this example, you start with the exponent of 2, and then you go higher, that is 8. So this is not a standard form. You always start with the largest exponent and then goes down to the smallest exponent. Let's take an example. Standard form of polynomials. So if I write x to the power 6 plus 3x to the power 3 plus 2x2 plus 4. You see here the exponent starts with 6, then it goes down to 3, then it goes down to 2, and then there is nothing. So this is standard form of polynomial. Before we decide standard form of polynomials, we should ask ourselves, is it a polynomial? Let's check. We have 1 term, 2 term, 3 term, 4 term. Yes, it's a polynomial. And then we will check whether it is in standard form or not. So it should go from largest exponent to smallest exponent. So we started with 6, then we went down to 3, then we went down to 2, and then we have nothing. Let's take another example. Example 2. So we start with 2x3 plus 9x2 plus 5x 11 minus 3x. So let's ask ourselves, is it a polynomial? 1, 2, 3, 4. Yes, this is a polynomial because it has more than one term. Many terms are there that are separated by plus and minus. Now let's check whether this is standard form of polynomial. Now, exponent x to the power cube. So our exponent is 3. Then our exponent is 2. We are good right now. But we often make a mistake by not going ahead and checking our problem completely. So we have to make sure that we check our exponent throughout entire expression. So this is 3. This is 2. Now here comes 11. You started decreasing on this side, but you are increasing on this side, okay? So let's check the last one, okay? If no exponent is given, by default, it is 1. By default, it is 1. So now you again started decreasing. So the pattern is decreasing, increasing, and decreasing. That's not the standard form. It has to be in the decreasing order of highest exponent. Our highest exponent in this question was 11. But we started with 3, then we went to 2, and then we went to 11. So this is not a standard form of polynomials. So why we are doing standard form of polynomials? Because when we add or subtract polynomials, we need to know what is a standard form. Our first step would be to arrange our expression in a standard form before we start adding and subtracting. So here are some examples how you can classify your polynomials by degree or by number of terms. By degree means we are talking about the exponent. Degree always tells you what's the exponent. So my polynomial is 5. What is a 5? 5 is a single term. That means it's a monomial. My degree is 0. We have no variable in that, and we have no exponent in that. And it is a constant because it's a single number that doesn't change. And by number of terms, we mean it's monomial. B, 2x minus 4. The degree is 1. If no exponent is given, by default, x is to the power 1. And it's a linear by degree because exponent 1 means it's a linear equation. How many terms are there? There are 2 terms that are separated by minus sign. Third one, 3x squared plus x. Again, there are 2 terms, so you can automatically say it's a binomial, just like your bike that has 2 tires. Now, the exponent, the highest exponent in 3x squared plus x is 2. If you have 2, that means quadratic, okay? The fourth part, x cubed minus 4x squared plus 1. The highest exponent is 3. It is a cubic term. And we have 3 terms that are separated by minus and a plus sign. That means it's a trinomial. You can see that each one of them are listed under polynomial because monomial, binomial, and trinomial makes a polynomial. So this was our first learning target, that I can understand polynomials. Now we will go ahead and start with our second learning target. I can add and subtract a polynomial. So adding a polynomial. Step 1, we have to check whether our polynomial is in standard form of polynomials or not. If it is not in a standard form, we should make it in a standard form. And second step, set up a addition problem. Third step, combine like terms. Make sure you only add coefficients. We will only add coefficients and we will leave our variables the way it is. So let's take an example and set up an addition problem. So this is our first example. We will break this problem into two parts because we have to add them. So let's check the first part. Our first part is x squared plus 4x plus 1. It has 3 terms. So it's a trinomial, that means it's a polynomial. And the second one, it has 4x squared minus 2, okay? Now, you must be wondering that why I have placed nothing in the middle, because it's always efficient to line up your terms according to the like terms. For example, at the first part, we have x squared. I have to add it with 4x squared. That's why I'm lining up in a straight vertical line so that I will add only like terms. Now, we don't have any x term in the second expression. So I can put a placeholder as 0x. It won't harm our expression. It will do nothing. It will just act like a placeholder. Now, if no coefficient is given in front of any variable, it is 1 by default. And now we can add our like terms. Remember, we will only add our coefficients. 1 plus 4 is 5. We will keep our variable the way it is. Plus 4 plus 0 is 4 with the variable. Now we have 1 plus minus 2. That would be negative 1. And that's how you're going to add your like terms. So what I did, I added my circle together because they were like terms. I added my square because these were the like terms. And I added my triangle because these were the like terms. Make sure you set up your problem in a standard form of polynomial. And then you can add your like terms by placing a placeholder if you don't have it. Okay? That was a first example of how to add a polynomial. So we can check our answer. We combine the like terms, the one with a single line. X squared goes with the 4x squared. So 1 plus 4 will come as 5x squared. And 4x, we have no x term, so 4x will remain the way it is. And yes, that's it. That's all you need to do to add a polynomial. So let's take another example. 6a cubed plus 12a squared minus 15a. And we have to add it with 4a squared minus 12a plus 8. So this is our second example. So first we will write it down, our first expression. This is an expression because it is not equal to anything. So if there is an equal to sign, that makes up an equation. So let's write our first term and let's set up our expression. Now you can check in this equation that our exponent is decreasing. That means it is in standard form. We checked out the first one. Now second one, we have a A2 term. We don't have a term with a cube. So let's write 4a square, that's positive. Then we have negative 12a, then we have positive 8. Now you can see that we need to place some placeholders because in the second expression, we don't have our cube term. We don't have an exponent with a 3 term. So we will write 0a cube. I've written down with a pencil. And in the first expression, we don't have a constant. So we can place a placeholder as 0. Now, since both the equations are in standard form and we have set up our equations, we can combine our like terms. So, 6 plus 0, 6. We will keep our variables the way it is. Now we have 12 plus 4, 16. We will keep our variables the way it is. The first one was square. We added the square because they are like terms. Second one is circle, okay? Now we have same signs. When you have same signs, you keep the sign and you add them. So we have negative 27a. We have same signs. We will add them. So this is my triangle. Now, constant is 0 plus 8, which is 8. So we have set up our equation first. We have placed our placeholders. There were 2 placeholders because we don't have enough terms. That's why we place a placeholder. And then we added our like terms. We will only add our coefficient. Okay, so this was the first part of our second learning target. We have added our polynomials. So now let's learn how to subtract our polynomials. Step 1 is still the same, like how we checked our polynomial is in standard form of polynomial or not. We will check the same thing. Is it in the standard form or not? That's a step 1. And then we will step 2 is set up the subtraction problem. Step 3. In subtraction, you have to make sure that we will distribute our subtraction sign to the second expression. Now let's see how it works, how this problem works. This is our problem. This is my part 1, and this is my part 2. Okay? My part 1 remains the same. We have 5x squared plus 3x minus 6. Now, this is my first step. Step 1. In step 2, we have to distribute our negative sign to the second expression. And each term, you have to distribute a negative sign. So negative times 3x squared is negative 3x squared. Negative times negative x becomes positive x. Negative times negative 5 becomes positive 5. Okay, now we will combine our like terms. So we have changed our subtraction problem into our addition problem. So 5x squared minus 3x squared, since both of them are like terms. So 5 minus 3 is 2x squared. Remember, we will only do arithmetic operations to our coefficients. We will not do anything to our variables. The next one is positive 3x and positive x. If no number is given, that means it is 1 by default. So this is 3 plus 1, that is 4x. And we have negative 6 plus 5. Negative 6 plus 5 is negative 1. And that's it. So our step 1 for our subtraction problem is check for standard form of polynomials. Step 2, write it down your first expression. Step 3, distribute subtraction sign to the second expression. Make sure in subtraction sign, to change subtraction of polynomial to addition, you have to distribute your negative sign to your second expression. And the last step is step 4, combine the like terms. So these are the steps which you can write it down. These are the steps. Step 1, check for standard form of polynomials. Step 2, write it down your first expression. Step 3, distribute subtraction sign to the second expression. Step 4, combine the like terms. Okay? So let's take another example. Subtract 6a cubed plus 12a squared minus 15a. And you have to subtract it from negative 4a squared minus 12a plus 8. So our step 1 is just check both the parts are in standard form of polynomial or not. So let's look at our first expression. If you see that the exponent is 3, then the exponent is 2, and then the exponent is 1. So yes, it is in the standard form. Our second expression, 4a squared minus 12a plus 8. So it starts with the a2. Exponent, highest exponent is 2, then it goes down to 1. Yes, this is also in standard form of polynomial. Our step 3 was we have to distribute our negative sign. So negative times 4a squared. Let's do that example. So we will write it down, our first expression, the way it is, which is 6a cubed plus 12a squared minus 15a. Now, before we write our second expression, we have to distribute our negative sign to our second expression. Negative times 4a squared is negative 4a squared. Negative times negative 12a is plus 12a, and negative times 8 is negative 8. So now we will write it down under our first expression. So negative 4a squared plus 12a minus 8. We have to place a placeholder because we don't have any a cube term, and we have to place a 0. So let's check what do we get. So if you look at the screen, we have 6 plus 0, we have 6a cube. We will have 12 minus 4a square, which is 8a square. Negative 15a plus 12a is negative 3a. And I think they forgot to put a negative 8 sign in the end. So we will have 6a cube plus 8a square minus 3a minus 8. So if you notice that we have placed a placeholder 0. So the question arises, why is there a 0 coefficient? There is a 0 coefficient because we don't have any a cube term in our second expression. And we have to place a placeholder so that we combine only our like terms. So this was an example 2 of subtraction of polynomials. So today we have discussed what is a polynomial, what is a standard form of polynomial, and how to add and subtract polynomials. So in the next slide, in the next upcoming session, we would be discussing our multiplication of polynomials soon. So this is a closing section. I want you all to try this, closing these 3 questions. The first one is, which of the following expressions are monomials with degree 2? So remember to check the exponent with the degree 2. Second question, identify the polynomial that is equivalent. The word equivalent means equal to. Equal to 4 minus 6v minus 7v square. And the third question is, from the list, which terms are like 5x, which is a monomial. So 5x, so you have to make sure that you try by yourself these questions based on the concepts discussed today. Thank you.